Let's see this question. It's about functions of matrices. So the question is, what is E raised by Euler number raised by that matrix? So let's recall Taylor's series. So in Taylor's series, E to the X can be represented as an infinite series like this. 1 plus X, so E raised by X divided by 1 factorial plus X squared divided by 2 factorial, X cubed plus 3 factorial. So in summation sign notation is index starting from 0 to infinity, because starting from 0, because we want to include 1 there. So X raised by K, then divided by K factorial. So E raised by X, this in Taylor's series is this representation. Now, so by that, we can define E raised by the matrix, especially this matrix is a square matrix. It could be 2 by 2, 3 by 3, so on and so forth. We could think this is like a special case of this, of E raised, because this is just 1 by 1, X is real value, it's just 1 by 1 matrix. So we can define E raised by a square matrix like this. So identity matrix, then the matrix divided by 1 factorial, matrix square divided by 2 factorial, so on and so forth. So in summation sign is very similar, right? So the matrix is raised by K's power divided by K factorial, and K start from 0 to infinity, because again, we have this identity matrix. So let's calculate an example to get some concrete idea. So let's see this example. So I made an easy one, okay, because to avoid a lot of calculations. So this matrix is a 2 by 2 matrix. So it's a 1, 1, 0, 0. Because this will be easy calculation, because a squared, a cube, a to the fourth, a to any power, and we still get back to the 8. Right, so this is an easy example. Then we just put into the definition of E raised by matrix. Right, this is the identity matrix. Then plus the matrix divided by 1 factorial, which is 1. This square, a square is still a. So then divided by 2 factorial. Then a cube, still a, divided by 3 factorial, so on and so forth. So in this case, we see a is a common factor. Right, so we can factor out a. Then the coefficient of the A matrix A, we have 1 plus half plus 6, which is 1 factorial, 1 divided by 1 factorial, plus 1 divided by 2 factorial, plus 1 divided by 3 factorial. Right? So that's just E minus 1. Right? So this is E minus 1. Because this one is 1 divided by 1 factorial. But in the definition of E, we have 1 plus this. Right? So we don't have, so that's why it's E minus 1. And a 1, 1, 0, 0 matrix is just 8, right? So now we can add, so we can multiply E minus 1 to the matrix 1, 1, 0, 0. So we get a matrix E minus 1, 0, 0. Then we add the identity matrix to it. So E minus 1 plus 1, that's just E. E minus 1 plus 0, that's E minus 1. And 0 plus 0, that's 0. Then 1 plus 0, that's 1. So in the end, E to the A, we get this solution. So it's a 2 by 2 matrix. So still 2 by 2 matrix. The entry in the first row, first column is just E. First row, second column, E minus 1. Second column, first row, 0. Second row, second column is 1. So still matrix, 2 by 2 matrix. You know, usually we don't write this way, right? Because we could be dealing with n by n matrices. So what we do is we use a summation sign. If we have E raised by A, or in this case, let's say minus identity matrix, right, on the left-hand side. Then on the right-hand side, we have this the summation of matrix raised by k's power divided by k factorial, and k goes from 0 to infinity. I see we could calculate it, then in the end, of course, we get the same answer when we add to when we move this I to the other side. So we still get the same. Oh, we don't have this anymore. No more. No, this sign, no more such sign anymore, because we already added here. We already involved the E. So from this moment on, no more E. So because this part, right, is E minus 1. That part is E minus 1. So no more summation sign here. That's a typo. Okay, so usually we write in this short notation sign, right? We don't really expand like that. All right, so that's a Q question, right? To calculate the E raised by n by n matrix.